when you guys are doing limit problems, okay, the nicest thing would be if they gave you a graph. Because if they gave you a graph, you can just read right off the graph. Does that make sense? Okay. But if you don't have a graph and you have a calculator, you could just do that tabular method, do the tables and figure out from the left and from the right what y value are you approaching. But if you don't have a calculator and they didn't give you a graph, and the graph is hard to draw, okay, then what you have to do is the algebraic method. And in the algebraic method, when you look at it, please don't just jump into factoring first. What do you do first? Plug in. Please plug in first. So if I plug in here, I'll get 9 plus 18 plus 5 over 9 minus 3 minus 6. Okay? This is going to be 27 plus 5 on the top there. So if I'm doing this right, I'm getting 32 over 0. If you get 32 over 0, what is your answer? D&E. So this is D&E. Is everybody good with that? I've talked to you about this before, and I'll just keep repeating it. It's okay to put equal signs here. But the problem is, if for some reason when you got here, this answer was 0 over 0, and you put an equal sign here, AP is going to dock you a point. Okay, so that's why I try to not put equal signs. But if you put an equal sign here, it's actually fine. All right, over here, let's go ahead and plug in. Okay, if I plug in, I get 4 minus 2 minus 2. On the bottom, I have 2 plus 2. So this will give me 0 over 4. If you get 0 over a number, what's your answer? 0. So this answer is just 0. Okay, and then finally, what's the answer at number 3? Nice. Okay, this is 7. Honestly, guys, it's a 50-50 chance. Okay, the answer is either E or 7. Okay, but the answer is 7. Why is the answer 7? Yeah. If you drew the function, okay, so let me ask you, is this the function or is this the function? The 7, okay? So this is the function. So if f of x is equal to 7, how do you draw that? What does that look like? A straight line. And if this is y equals 7, what is this number right here? 7. And what is e? Does anybody know what e is? I know what number it is. 2 point what? Is it 2.7? I don't really. Okay. So if it's 2.7, okay, you go find e on your x axis, and you go up and you get the y value here. You see that? And that y value is 7. So that's why this is 7. But if you did this algebraically, you'd also get 7. Because let's think about what algebraically this is saying. This is saying everywhere there's an x, go put an e in it. Okay? And do you see any x's here? No. So this is the answer, 7. Okay? Again, guys, please don't give me e. That would be the wrong answer. But I know it's just a guess for some of you guys. So I guess it's a 50-50 chance. Okay, what if I did this? That's a pi. What would the answer here now? Pi. Okay. What if I did this? What's the answer now? 7. Everyone good with that? Okay. Let's look at this problem. Okay. First, we're going to plug in. So everywhere there's an x, this says everywhere there's an x, put in -5. So that's 3. -5 squared is not -25, it's +25. Is everybody good with that? Okay. And then on the bottom, we'll plug in -5. So on the top here, I'll have 75 minus 65 minus 10. On the bottom, I'll have 0. And this is actually 0 over 0. Do you agree? Okay. It's okay to put an equal here where there's already an equal, but it's not okay to put an equal here. So that's why I'm leaving a gap. You can put an arrow, like some people might want to put something, you put an arrow if you want. You can put an emoji if you want. Okay. You just can't put an equal sign. All right. What do you do, guys, when you get 0 over 0? Okay. Oh, gotta do something else. What's your first something else? Factoring. Okay, so I'm going to try to factor this. So this would be the limit as x approaches -5. And the way I factor, and I don't really care how you factor, you be you, okay? But the way I factor is I say, what times what gives me 3x? And I say, well, it's going to be 3x times x. And then I say, what times what gives me 10? And I'll say, okay, let me try 5 and 2. And then what I do, I multiply these together. So that's 5x, and this is 6x. And I say, okay, can I add or subtract them somehow to get 13? And that's, if I subtract, I get 1. If I add, I get 11. So I'm like, no, that doesn't work. So then I switch the 5 and the 2. So I put the 2 over here, and I put the 5 over here. Then I do the same thing. When I multiply these, I get 2x. When I multiply these, I get 15x. And I say, is there a way to add or subtract these to get 13? Yes. If I had a positive 15 and a negative 2, I would get 13. So then I go back and I say, okay, this needs to be negative 2x. This needs to be positive 15x. And I do a double check. Does negative 2 times 5 give me negative 10? Check. And then everything else works out. That's how I do it. But again, I really don't care how you factor. I just want you to be able to factor. And if you can't factor, please spend 30 minutes on Khan Academy, and that'll be a very good investment of your time. Okay? All right. The reason I factor is I'm hoping something will cancel out. Okay? Does anything cancel out? Yes. What cancels out? What does the x plus 5 cancel to? It doesn't just disappear. It cancels to 1. So what I end up getting is a limit as x approaches negative 5 of 3x minus 2. And what do you do now? You plug in. So this is going to give you 3 times negative 5 minus 2, which will give you negative 17. Did you get negative 17? Nice. Okay, just some caveats. A lot of students who don't carry down this limit, so like some students won't carry down this limit and they'll leave it here. And so what happens when you don't carry down the limit is you never plug in x. Is everybody good with that? I don't care if you don't carry down the limits, but it'd be nice if you got the right answer. Okay.
We use points on AP if you don't carry down limits.
Only if you put equal signs. If you don't put equal signs, you'll be totally fine. Okay, as long as you get the right answer. All right. Let's look at your homework from last night. These are your answers. The front side. You're going to finish the back side tomorrow. This is the front side. What questions do you have? Easy? No questions. You sure? Yeah.
Is there a difference between D and E and undefined?
No. Yeah. There probably is a slight difference. I just don't know what it is. But with limits, you almost never see undefined just because you usually say the limit doesn't exist. So it's usually the limit. Let's go to this right here. I don't know. I think it might be today's homework. I'm sorry, today's notes. So if you look at today's notes, do you see something that looks like this? Yeah? No? Yesterday's notes. If you look at yesterday's notes, do you see something that looks like this? Do you guys have yesterday's notes? Oh, yesterday's notes.
It's on today's.
It's on today's notes? It's not as oh, is it today's notes? Yeah, I want today's notes. Yeah, it's on today's notes. Okay. So right here, guys, okay, whenever you do a problem, an algebraic problem, the easiest thing, in my opinion, is just plug in and see what happens. Okay. When I plug in, do you see I get 0 over 0? Okay, so, gotta do something else. Now, the factorings, I mean, it is kind of factored already, but I want you guys to make sure you understand, you can't cancel these out. The reason is because one is an absolute value and one's not. So there's kind of a sign thing that you need to take into account. And so you can't just be like, oh, I just want to factor things out, so I'll factor it out, okay? So the easiest thing to do for a problem with the absolute value, and I think you guys know this, is to sketch it, okay? Because you know how to sketch this picture. This picture, okay, its parent function looks like what? 1, right? So this is negative 1 here, right? And how is this picture shifted? To the right by 3. So I'm going to pull this over to the right by 3. So pull this over to the right by 3. And when you do that, where is the jump now? It was at 0. Where is it now? 3. Okay, then you can answer all these questions. So looking at this graph, as x approaches 3 from the right, what's your y value? 1. As x approaches 3 from the left, what's your y value? Negative 1. What if you drop the left and the right? What is your limit now? D and E. Is everybody good there? What happens when I take this absolute value, okay, and I flip it to the bottom? Okay, what happens? the same. Everybody agree with that? The picture looks exactly the same. So I already know all of these answers also. All right. Now I want you guys to look at this problem right here. Okay. This problem right here, when I plug in the 3, so let me go ahead and plug in 3, I'll get 9 and 3. You see you get 0 over the absolute value of 0, which is 0 over 0. Okay, so, gotta do something else. But it's super hard to graph this picture, okay? And so what I'm going to do is I'm going to manipulate it. I mean, if you had a graph, you would just read off the graph. If you had a calculator and you knew how to enter absolute value into your calculator, you could just do a table and figure out what the answer is, okay? But if I don't have a calculator and I don't know how to draw the graph, okay, you can do it algebraically, but you got to be smart about it. So let me show you how you do this. I'm going to factor the bottom down here, okay? So go ahead and factor the bottom. Do not cancel at this point. You cannot cancel because of these absolute values. Okay, absolute values, they change the sign. They play with the sign, so you can't just cancel. Okay, but one thing you know is that, do you agree that this down here is always going to be positive? Because it's absolute value, right? And if you multiply a number by another number, even if one of these is negative, it's the same as multiplying something positive by something positive, right? Because your answer is always going to be positive. So what you're allowed to do here is you're allowed to split this up into 2 factors that are both absolute values, okay? Now, it's not easy with absolute values. You can't just like, you do any rule you want. But for product, for 2 things being multiplied together, that's inside an absolute value like this, you can split it up and put them into separate absolute value signs, okay? Still, though, even though you want to cancel here, you cannot because of this absolute value. But what you can do is use limit properties that we learned yesterday. We learned that if you can split this into 2 fractions, okay, and do you agree that this fraction, oops, let me do this fraction is the same as this fraction? Do you believe that? If I can split it into 2 fractions, do you remember what limit rules allowed me to do? Allowed me to like, kind of distribute that limit. Okay, I'm using the word distribute, but that's actually not the right math word. But I'm using it because you guys know what distribute means. Okay, so I'm going to distribute that and put a multiplication in the middle. So this is the same as a limit as x approaches 3 from the right of x minus 3 over the absolute value of x minus 3 times the limit as x approaches 3 from the right of 1 over x plus 2 absolute value. Okay, and if I found this limit, and I found this limit, and I multiplied them together, then I can get the answer. What is the answer to this left limit? Is it 1? Okay. What is the answer to this right limit? Are you guys seeing 1 over 5? So do you see that this final answer is 1 6? You guys see how that works? Okay. Can you guys do the same, using the same principles? Can you do this problem for me, please? Using the same principles, you do this one on your own. It's 0 over 0. But 0 over 0 is indeterminate. So you have to figure out what that answer is. Look, do it up here.
Oh, gotcha.
Okay, so let me do this one with you guys. Okay, so again, I'm going to take this problem and I'm going to plug in 3. So if I plug in 3, I know this is 3 from the left, but you always can just plug in 3. If you get an answer, then that's great. If you don't get an answer, then that's when you have to think about from the left, from the right. Okay, if this gave me an answer, then it's great. So this is going to be not a good answer. Okay, So class, what do you say when you get 0 over 0? Oh, gotta do something else. Okay, so the first something else is factoring. So let me think about that. Let me rewrite this in a way that maybe I can factor. Actually, I'm just going to rewrite this. Are you guys okay if I just do this? Okay, so you get the same thing over here, except this is a negative. This is a from the left now. So then what I'm going to do is I'm going to split this into two functions. So this becomes the limit as x approaches 3 from the left of x minus 3 over the absolute value of x minus 3 times the limit as x approaches 3 from the left of 1 over x plus 2 absolute value. Okay? What is this answer right here? Negative 1. What is this answer right here? 3, right? If you can plug in a 3 and you get an answer, then that's the answer. So if I plug in a 3, do you see you get 1 over positive 5? Okay, so what's this final answer? Negative 1/5. Over here, if you plug in a 3, do you see you get 0 over 0? So that's, oh, gotta do something else. So this over here isn't as easy as this 1/5 on this side. And again, students a lot of times will argue with me, well, I got 1/5 and the answer is negative 1/5. I was pretty close. Do you think you're close? Would you rather owe me $1 million or have $1 million? Okay, I feel like that's pretty far away from each other. Okay, so the negative is important. All right. Okay. Any questions on the absolute value thing? All right. What I want you to do is, let's see, go to last night's notes. Go to yesterday's notes. Sorry, yesterday's notes, and we're going to finish that up. We're going to talk about conjugate pairs. Okay. When you do limits algebraically, okay, what is the first thing you do? Plug in. You always plug in first. Okay. It'd be so easy for me to trick you on this. Okay. If your answer is a number, that is your answer, the number. If your answer is 0 over a number, then what is your answer? 0. If your answer is a number over 0, then what is your answer? D and E. And what if your answer is 0 over 0? Okay. Oh, gotta do something else. And if you had a calculator, you might be able to just do tables. If you knew what the picture looked like, you would just use the picture. Okay. But I'm also going to give you 4 more tools you can use. 1 is factoring, which we did last night. 2 is conjugate pairs, which we're about to do. Okay. 3 is common denominator, which we're about to do. And then finally, multiply out and distribute, which is kind of a special case, and I'll show you how to do that today too. Okay. So let's start with conjugate pairs. First of all, you need to know what a conjugate pair is. Okay. So conjugate pair is if I give you the square root of x plus 1, okay, you can tell me its conjugate pair. What is a conjugate pair of the square root of x plus 1? Okay, there's a special thing about conjugate pairs. When you multiply them together, you get the difference of 2 squares. Okay, that's why conjugate pairs is kind of tricking the problem. Okay, because you get a result that you want. And so if I multiply these two together, do you see I would get the square of the square root of x? So do you see that's x? I would get the square of 1. You see that that's 1. And then I would just slap a minus sign in the middle because that's the difference of 2 squares. A lot of times students will ask me, well, what sign goes in the middle here? Okay, is it sometimes plus and sometimes minus? No, it's always minus. Everybody give it that? It's a difference of 2 squares. Okay, so knowing this special trick for conjugate pairs, we can do some of these problems. So here's the typical problem of conjugate pairs. We have a square root somewhere. But guys, even if you have a square root, you always plug in first. So everybody good with that. Okay. So I'm going to plug in a 4 here. I'm going to plug in a 4 here. And so that gives me the square root of 1 minus 1 over 0. And do you see 0 over 0? Okay. So, oh, gotta do something else. Okay. Got a graph. I would just look at the graph. If I had a calculator, I could do a table. If it were factoring, I could try that. Okay. But none of that works. So I'm going to do conjugate pairs. What conjugate pairs does, and a trick to see if it's a conjugate pair problem, is to see if you have a square root here or a sine x minus cosine x. Sine x minus cosine x is actually another tricky conjugate pair that you could do. Okay, but this one is going to be a square root problem. So what I do is I multiply this by its conjugate pair. So I put its conjugate pair right there. okay? But I'm tricking this problem, but you can't just go out and just multiply by anything you want, okay? But you can multiply by 1. Everybody good with that? So to multiply by 1, I'm going to multiply the top by its conjugate pair, but I'm also going to multiply the bottom, the denominator of this problem, by the same number. So whatever this top number I'm multiplying is, I'm going to multiply the bottom by it. So what I'm going to do is I'm going to multiply this fraction by this fraction. And does everybody agree that this fraction is 1? It better be 1. If it's -1, I can't do it. Okay, it's got to be 1. So I'm just going to multiply this by 1, and I should get something that's equivalent because that's a property, right? So what I'm going to do is I'm going to do multiplying fraction. It's no problem. Top times top, bottom times bottom. Okay, so we're going to multiply top times top. This is going to be the square root. Oops, let me do this. This is a minus b. This is a plus b. Do you agree with that? So the answer is going to be a squared minus b squared. Do you agree with that? Okay. So if I take this and square it, what do I get? X minus 3. If I take the 1 and square it, what do I get? 1. And what sign always do I snap in the middle? Minus. Okay. On the denominator. I know you guys want to FOIL this. Okay. Don't FOIL it. It's going to become a giant mess. Okay. All I want you to do is resist the urge to FOIL. Okay. And go ahead and just copy down what you have. Make sure you understand that when you have a denominator, it's a family, okay? So it's in parentheses, it's a quantity, it's a grouping. This denominator here is also a grouping. So you can't take the x minus 4 out of its family, okay? Do we break up families in real life? Is that cool? No, you're not going to break them up in calculus either, okay? So this is, you're just going to leave it like this. The reason you leave it like this is because something's going to always factor here, if it is a 0 over 0 problem. Do you see what factors? The x minus 4. Do you see you really have x minus 4 up here? So this is going to factor with this. And what does it turn into when you cancel two things like this? It turns into a 1. Okay? Guys, it doesn't disappear. It doesn't turn into a 0. Okay? It turns into a 1. So there still is a 1 up there on the top. Okay? Please don't flip the denominator. Please don't make things disappear. Okay? It actually turns into a 1. All right. So this is a problem I have. And at this point, what can you do? You can plug in. So what I do is I plug in. When you plug in, you can drop that limit notation. So I get 4 minus 3 plus 1. And so I get 1 over 1 plus 1. And the answer is 1/2. How are you feeling about that? Nice, right? If you're good at algebra and you like algebra, you like manipulating things, you'll like these conjugate pair problems. Okay, so let's look at this problem. What's the first thing you guys do? Plug in. Please plug in first. If I put a 0 everywhere there's an x, this tells me what to plug in. I'll get 1 minus 1 over 0. And what do I get here? Oh, gotta do something else. You know, if you were a tricky teacher, and I am, if you were a tricky teacher, you might think about giving a problem on the test where, like, there's a 3 down here. And a student will go through all this conjugate pair thing, when really, what was the answer? 0. Is everybody good with that? So please don't just jump into conjugate pairs. Is everybody good with that? Please, what is the first step for every limit problem that you do? Plug in, okay? So this was 0 over 0, though, so I'm going to go ahead and do conjugate pairs, okay? So the conjugate pair of the square root of x plus 1 minus 1 is actually x plus square root of x plus 1 plus 1, okay? A very common thing that students do is instead of just changing this sign right here, so do you see this negative turns to a plus? They change every single sign, okay? That's not how you do conjugate pairs, let me just tell you, okay? You copy the whole A term, you copy the whole B term, and then you put the opposite sign in the middle, okay? Please don't just change every single sign. That's not what we're doing, all right? If I multiply by A plus B, okay, then I also have to put what on the bottom here? A plus B. Is everybody good with that? I have to put the exact same thing. The other mistake students do is they make these conjugate pairs, this top and the bottom here. Do these need to be conjugate pairs? No. We're making the left and right conjugate pairs. Everybody good with that? Okay? Whatever you do, this right here must be equal to 1. If it's not equal to 1, then you're doing a multiplication that's not allowed. All right, we're going to do multiplication of fractions, okay? Multiplying fractions, it's no problem. Top times top, bottom times bottom, okay? So the top times the top, you did A minus B times A plus B. You tricked it into making it like that, okay? So you did it, okay? You can't blame the problem. So do you see what A times A is going to be here? What's A squared going to be? X plus 1. What's 1 times 1 going to be? 1. What sign do I put in the middle? Always, always minus, not a plus sign, always minus, okay? On the bottom, do you see this X is a family in itself? Okay, so this will be X times, do you see the square root of X plus 1, square root of blah, blah, plus 1 will be a family in itself, okay? So this stays in parentheses also, guys. Keep the families, okay? Leave them alone, okay? Don't break up families. Take a step back. Is there something I can cancel? Yes. What's the numerator really here? X. So do you see that X's will cancel? What do they cancel to? 1. Okay? This becomes the limit as X approaches 0. Please don't just make the 1 disappear. There really still is a 1 there. Okay? What is your next step? Plug in. Plug in what?
0.
0 for what? X. Only for the X. So this is 0. So what I get is 1 over the square root of 1 plus 1. And the answer is 1/2. Any questions? All right, notice that the last problem we did, the answer was 1/2. This problem, the answer is 1/2. Guys, the answer is not always 1/2. It's just a coincidence. Don't just put 1/2 for every conjugate pair problem, okay? That's just a coincidence, okay? All right. See, I'm ahead of you guys. I feel like I know what you guys are up to. Okay, common denominator. How do we know when there's a common denominator problem? The easiest way to suspect is when you have a fraction in a fraction. You see that? Because they're taking common denominator. All right? But first, guys, what do you always do first? Plug in. Okay, so everywhere there's an x, put in 10. So this will be 10. This will be 10. This will be 1/7 minus 1/7 over 0. So you get 0 over 0. And class, what do we say? Oh, gotta do something else. Okay? So then what we're going to do is we're going to think, okay, I think this is a common denominator problem. And really when we say common denominator, all we're saying is we want to get this into one fraction. If we could get this into one fraction, it'll be one fraction divided by one fraction. And this fraction here is divided by 1. Okay, so it'll be a fraction divided by a fraction. And we can do the easiest pi things. Dividing fractions, easiest pi, flip the second and multiply. Okay, so I just want this into one fraction. So to get this into one fraction, I need a common denominator here. So this common denominator is going to be 7 times x minus 3. Okay? So if I want a common denominator of 7 times x minus 3, this already has an x minus 3. So I need to multiply by 7 on the top and the bottom. So the first term here becomes 7 over 7x minus 3. On this side, the right side, I need 7 times x minus 3. Well, this already has a 7. It just needs x minus 3. So I multiply by x minus 3 on this side. So I get minus x minus 3 over, well, I won't put that in parentheses just yet, x minus 3 over 7 times x minus 3. Okay? This minus sign here was just a carry down from this. Okay? So that's my numerator. I'm trying to get a common denominator. On the bottom, I have x minus 10, and this is still a limit problem. Okay. Are you guys with me so far? Okay. On this right here, I want to make the numerator into one fraction. So to do that, what I'm going to do is keep that same denominator, okay? And this will be 7 minus, and be very careful. This is a family, x minus 3. Do we break up families in calculus? No. Do we break up families in real life? No. See how much you're learning here? Okay. So this negative is actually going to be distributed. So just forget that. Okay. So this is going to be 7 minus x plus 3. You're distributing that negative sign. Okay. This is still let's see, over x minus 10, and it's still the limit as x goes to 10. I want to just look at this numerator right here. What is 7 minus x plus 3? Yeah, it's really, I'm going to say negative x plus 10. It is 10 minus x. But I'm going to say negative x plus 10. It's a little bit easier to manipulate that way. So what I have is one fraction on the top. I can make it a fraction on the bottom, okay? And so now I can do dividing fractions easy as pie, okay? Write the first fraction, and then flip the second and multiply. Dividing fractions easy as pie, flip the second and multiply. You're going to have to make the bottom a fraction, so it's really x minus 10 over 1. And the reason for doing this is something's going to cancel out, but not quite yet, okay? Why can I not cancel out the negative x plus 10 and x minus 10? They're not exactly the same, unless I do what? Unless I take out a negative 1. You guys see that? If I take out a negative 1, I'll get x minus 10 there. And so if I do that, do you see now the x minus 10s cancel, okay? They don't just disappear though. What do they cancel to? 1. This becomes a limit as x goes to 10 of negative 1 over 7 times the quantity x plus 3. I'm ready to plug in. I think I'm ready. This will be negative 1 over 7 times, I really have the wrong answer here, so I must have done something wrong. Oh, this is minus 3. Thank you. This should be a minus 3. So this is 10 minus 3. So what is this answer? Any questions about common denominator? Okay, you guys do this one on your own. This one right here.
Well, you're thinking of multiply it. You gotta take something out of that.
It'll happen again on this problem.
Yeah.
Okay, guys, let's get started here. This is going to be first you plug in. And so do you see you get 0 over 0? Okay. Oh, gotta do something else. I notice I have a fraction and a fraction. Okay. So I'm going to get a common denominator right here. And between these two factors, I multiply them together. And so do you see my common denominator is x minus 1? Okay. This one already has an x minus 1. Okay. So what I'm going to do is leave it alone. This one right here doesn't have an x minus 1. So I need to multiply this one by x minus 1. But if I multiply the bottom by x minus 1, I got to multiply the top by x minus 1 also. This negative sign here, I'm just going to carry right there. On the bottom, I still have x minus 2. And of course, this is still a limit problem. All right. Then I'm just going to, because I have a common denominator, I can combine this into one fraction. That's how adding and subtracting fractions work. So I have an x minus 1. That's the common denominator. Then I have this minus this. So I have 1 minus, and make sure you understand, this is a family. This is 1 minus x minus 1 all over x minus 2, and this is a limit problem. Okay. This negative here distributes, so this becomes 1 minus x plus 1 over x minus 1 all over x minus 2. And of course, the limit still exists. I haven't taken the limit yet. Oh, sorry, x goes to 2. Okay, right here, it's a little tricky, but what is this right here? If I add 1 minus x plus 1, negative x plus 2. You see that? I know it's 2 minus x, but it's a lot easier if you leave the x first. So negative x plus 2. So what I have is really here, negative x plus 2 over x minus 1 on the top. On the bottom, I also have a fraction. Okay, and so what I can do is say dividing fractions easy as pie. Okay, leave the first alone, flip the second, and multiply. Do you see where I'm getting the first and the second? Okay, this is just like the last problem. You cannot cancel these out. They're not the same. You guys see that they're not the same. They're opposites of each other. But how can you get this thing to cancel out? Take out a negative 1. Okay, if I take out a negative 1, I factor a negative 1 out here. This is exactly the same. Think about it. Redistribute this. Do I get negative x plus 2 when I redistribute it? Yeah, it's exactly the same. And the trick is, because I can make it like that, do you see now the x minus 2 cancel? But they don't just disappear. Okay, what do they cancel to? 1. So this becomes a limit as x goes to 2 of negative 1 over x minus 1. X minus 1. Is everybody good? And then I'm ready to go ahead and put in the 2. If I plug in the 2, I get -1/1, which is, did you guys get -1? And that's how you do this problem. All right, pat yourself on the back if you did it right. Okay, now we know everybody did it wrong. It's okay. All right, I want to also talk to you guys about distributing and simplifying. So you could also get a problem that looks like this. Okay, so this is somewhere on your notes. This is really the definition of a derivative. Okay, you're going to learn this in about 2 weeks. All right, really, it looks really bad, but it's just a definition of a derivative. Okay, it's a little bit different because we're not plugging in x. Okay, we're actually plugging in what? Into what letter? H. Everywhere there's an H, I'm going to put in a 0. Leave the x's alone. This says everywhere there's an H, you're going to plug in a 0. As H approaches 0. So everywhere there's an H, we're going to put in a 0. Okay? If you do that, what you get is x squared minus 4x plus 7. Okay? Minus x squared minus 4x plus 7. Okay? And you have a 0 on the bottom. So do you see you get 0 over 0? Okay? This is specially concocted to get 0 over 0. So don't worry, that's so ugly. Okay, but this is going to be eventually what we learn. It's a definition of a derivative. So then you would say, oh, gotta do something else. Okay, and what that something else here is get rid of the parentheses. Distribute like crazy and get rid of all the parentheses. Okay, so this right here, I'm going to FOIL this. This is going to be x plus h times x plus h. Okay, so this becomes the limit as h goes to 0 of x squared plus 2xh plus h squared. Right? Right here, I'm going to distribute the -4. So this becomes -4x minus 4h. Here, I'm just going to copy down the 7. And then finally here, I'm going to distribute the negative. So this will be -x squared plus 4x minus 7. Okay, all over h. Okay, what I'm going to do here is I'm going to distribute. The reason I'm distributing is because things are going to cancel when I distribute. Take a look at this. Do you see that x squared minus x squared cancel out? Okay. Do you see that, let's see, the 4x and the -4x cancel out? And then there's another one that cancels out, the 7. The +7 and -7 cancel out. What do they cancel out to here? Is it 1 or 0? It's 0. Okay, you get +0 here. So what you have now is a limit as h goes to 0 of 2xh plus h squared minus 4h over h. Okay. Now leave the x's alone. It's okay to have x in the answer. I know you're not used to it, but it's okay. What we're going to do is everywhere there's an h, I'm going to plug in 0. And if I do that, well, I shouldn't put an equal sign. If I do that, do you see I get 0 over 0? So class, what do you say? Oh, gotta do something else. What's the first something else that we learned? Factoring. Can you factor anything out of this top H? Okay. A hint is look at the bottom. Because if you look at the bottom, that's what you want to cancel out. Okay. So let's factor out an H and see what happens. If you factor out an H here, okay, and here's where students get stuck. They factor out an H, but they don't do anything about it. Why did we factor out the H? Yeah, we're hoping to cancel it, okay? So if you cancel it out, what you get is a limit as H goes to 0 of this expression, 2x plus H minus 4. And this expression says, everywhere there's an H, what am I going to plug in?
0.
A 0. So this answer is going to be 2x minus 4 when I plug in. Anybody here know derivatives already? Anybody? You did? A little bit? Okay. Yeah, this is a formal definition of a derivative. Oh, wow, that's so incredibly smart. Okay, so this answer is 2x minus 4. So we were taking the derivative of x squared minus 4x plus 7. So if you know derivatives already, you're going to be like, wow. Okay, but if you don't, then we're going to learn it in 2 weeks. Okay? All right, so it's okay to have an x in these answers. And the final thing I want to talk to you guys about is the squeeze theorem or the sandwich theorem, which doesn't really fit anywhere except it's about limits. So I need to tell you about the squeeze theorem and the sandwich, or the sandwich theorem, and this is what it says. It says, if you have a function f of x, okay, and f of x is always between a big function and a small function. There's something really big on top of it and really small below it, or bigger than it and smaller than it. And at some point it's squeezed, it's pinched, okay? If you found an x value, so this x value is c, we'll call it, could be 3, could be 5, okay? At some x value for all of them, it has to be the same x value, okay? And if you found the limit, let me pull this up a little bit. If you found the limit of g at that x value, and you found the limit of h at the x value, you found the limits of the upper and lower functions, and that answer is L, that answer is the same, say it's 5, that answer is 5, okay? Then what that means is the limit at c of this f of x is also 5, okay? Does that make sense? Like if this f is squeezed in between two limits, if the top limit is the same as the bottom limit, then the f must have the same limit. Okay, that's what it's saying. Okay, so let me show you what it looks like. Okay, this is the problem right here. It says if the upper and lower limits, okay, but you have to find it has to be the same x value. So this is the x value of c. Has some x value. They're exactly the same, and f sits between those two, or is equal to those two in every single domain, every part of this domain, then f has the same limit. That's what it's saying. Okay, so let's look at a problem. This could be a problem right here. Okay, so sometimes you know the function. So for example, it says f is between this upper function and this lower function. Okay, they tell you it is. It's between it. Okay, and so if you find, they're saying, okay, tell me the limit of f of x as x approaches 0. Okay, so this here, they're telling you, do this limit right here. They tell you what the limit should be. So take the limit of the lower limit, the limit of the lower function, sorry. So limit as x goes to 0 of 2, and take the limit of the upper limit, upper function, sorry. The limit as x goes to 0 of x squared plus 2. Okay, so this tells you what limit to take. And do that for the upper and lower limits. Keep saying limits, upper and lower functions. Okay? And if they are the same, then this one has the same limit. Does that make sense? Because this one's stuck in between them. Okay, and guys, if they're telling you to use the squeeze theorem, they will be the same. Okay, so what's the answer here? 2. What's the answer here? Plug in 0. 2. So guess what the answer here is? 2. You guys see how that works? And if you look at the picture, look, what if I graph y equals 2? Do you see it's this green graph right here? And what if I graph y equals x squared plus 2? Do you see it's this green graph right here? Do you see the pinch place? Do you see the squeeze place? Okay. So if I take the limit at 0, do you see it? The limit value is 2 both times. So guess what the limit is for some function in the middle? It has to be 2. Does that make sense? Okay.
In this problem, it says use the squeeze theorem to find the limit as x approaches 0 of f of x. Here f of x is x sine 1 over x, and that's this red function right here. This is kind of like the crazy oscillation function, but not quite, because it's being multiplied by x, which moderates this crazy oscillation a little bit right here at x equals 0. So it's not exactly the crazy oscillation here. Also, we know that this red function, f of x, is between this y equals absolute value of x. So this function at the top here is y equals absolute value of x. And this bottom function, this green function here, is y equals negative absolute value of x. And so we know that by looking at the picture, we can see that absolute value of x sits between, the absolute value of x is the upper bound, and f of x sits between the absolute value of x and negative absolute value of x. So we've got this kind of the squeeze theorem format here, where there's a function that is squeezed between two other functions. If we take the limit of each of these parts, and this right here tells us what limit we need to take. So we need to take the limit as x approaches 0 of each of these components of this inequality. And it turns out If these two answers are the same, the lower bound limit and the upper bound limit is the same, then this answer is also the same limit. There has to be an answer though, it can't be D and E. So if I plug in 0 here, I'll get negative absolute value of 0, which is negative 0, which is really just 0. And then on the right side, on the upper bound here, if I plug in 0, I'll get the absolute value of 0. And that is really just 0. So if this answer here is 0, and this answer here is 0, then what we know is this middle answer, because of the squeeze theorem, is also 0.